Okay, hi, we're back again. This is the second lecture since spring break, so since we stopped being able to hold classes. So today we're going to start talking about interactions. So if I'll get this going. Okay, so far we've talked mainly about main effects models. So what do we mean by that? So this is kind of the general main effects model form that we've been working with. So notice all these pluses, so everything is additive basically. So what does it mean to say this is a main effects model? We could say all predictors are main effects. There are no terms of order higher than 1. So recall that order is just the sum of the powers in a term. So if you think implicitly up here, there's a 1, so it's the exponent. So everything is raised to a power of 1. So there are no polynomial terms like we talked about with curvilinear regression models. And also there are no interactions, which is what we'll talk about today. What does it mean to say it's a main effects model? We could say that the effects of the different predictors on the dependent variable are additive. So all of these effects, kind of represented by these coefficients, they all add up and kind of affect our predicted y variable. We could also say that the effects of the different predictors on the dependent variable are independent of one another. We could say that the effect of one predictor on the dependent variable does not depend on the level of any other predictor. Obviously, these are all just kind of saying the same thing, basically. So one exception that we've talked about so far is polynomial models. So this was our simplest polynomial form. Okay, so it's not a main effects model because there's a higher order term, so we have a squared term, so it's higher than order 1. The effect of the predictor on the dependent variable is multiplicative. So see this multiplication sign. We're multiplying the predictor by itself. And the effect of the predictor on the dependent variable does depend on the level of the predictor being considered. So the only predictor, of course, is x in that case. Here, we'll talk about interactions with another predictor, not just basically the predictor interacting with itself. Okay, so recall that we also use simple slopes to tell the effect of the predictor on the dependent variable at different levels of the other predictor, or that same predictor. Okay, so we'll be doing something similar here by looking at simple slopes later today. So models with interaction terms are also not main effects models. So here's our simplest form of a model with an interaction term. Okay, so we have an intercept, and then we have coefficients for each predictor, predictor x1 and x2. And then here's our interaction term over here. We multiply the values of the predictors together. So it's not a main effects order because remember it's not a main effects model because remember the order is based on the sum of the exponents. So we have a 1 here and a 1 here, and whenever we multiply values together, their exponents sum together. So it's 1 plus 1, so it's of an order of 2. Okay, so the effect of the predictor on the dependent variable is now no longer just additive, it's multiplicative. Okay, and so we could say that the effects of the different predictors on the dependent variable are dependent on one another. Okay, so we could also say the effect of one predictor on the dependent variable depends on the level of the other predictor being considered. So we're thinking, what is the effect of variable x1 or a on outcome variable y? Well, it depends on what the value is of the other variable, because that relationship between x1 and y will change depending on what the level is of the other predictor if you have a significant interaction term. Okay, so we're going to look at an example. I think this is kind of appropriate given our new way of life, basically. So say we're trying to predict how satisfied people are with their social lives. So maybe they're not so satisfied right now, since social lives seem kind of non-existent. Okay, so our predictors are extroversion, so really relevant now. If you're more introverted, maybe, this is just life as normal to you. If you're more extroverted, staying inside and social distancing might seem like a big deal and a big change in your way of life. Okay, so maybe we give some scale on extroversion. So, for example, the Big Five personality inventory is one. You get that's one of the factors is extroversion versus introversion. So maybe that's one scale. We measure it extroversion by a scale, and then a number of different people each person had a conversation with in a day. Okay, so there's a bunch of people. You know, right now we're thinking I don't want to be around people because they might have coronavirus, but that's the other variable for this example. Okay, so we gather data from 80 people. Our variables are extroversion rated on a scale from 0 to 100, number of people that the participant had conversations with that day from 1 to 13, satisfaction with social life from 1 to 25. So just some self-report scale about satisfaction with social life. Okay, so here are the results. If we just took those two predictors, extroversion, satisfaction with social life, and ran them in a main effects model, here would be our results. Okay, so it looks like both predictors have p-values well below 0.05, so we would say that they're significant. So both extroversion and number of people talked to are significant predictors of satisfaction with social life. Okay, so there is our regression equation. We've got the intercept there, the slope for extroversion, and then the slope for number of people talked to right there. So what if we calculated predicted scores by just varying the number of people that someone talked to? So we have a person scoring 20 on extroversion who talked to 5 people. We plug those values in, 20 for extroversion, 5 for number of people talked to. This is from our additive regression model. And then we get a predicted satisfaction with social life of 6.293. Okay, so the person also scoring 20 on extroversion, but this person talked to 6 people. Their predicted score would be 6.892. So again, we can just plug in the values for each coefficient or each predictor, okay, and then multiply them by the regression coefficients. Okay, so what's the difference based on that increasing one number of people talked to while holding extroversion constant? If we take this value for 6 people minus this value for 5 people, we get a difference of 0.599. So the one additional person talked to is associated with the predicted 0.599 increase in satisfaction with social life. And that's no surprise. This is like what we've been learning so far. That's given by this regression coefficient. So I held everything else constant. I just increased number of people talked to, and it just basically adds up. So you add one person that more that a person has talked to, and then that is associated with a 0.599 increase in satisfaction with social life, and that's exactly what we found. We could do another example. So now a person scoring 21 on extroversion who talked to 5 people. There's their predicted score. A person scoring 21 on extroversion, so same value here, but this person talked to one more person. They would have a predicted satisfaction with social life of 7.085. That difference, just by a 1 unit increase in number of people talked to, is associated with a 0.599 increase in satisfaction with social life. And again, it matches the coefficient. Okay, so the predicted effect of increasing number of people talked to by 1 was to increase satisfaction with social life by 0.599. So that's exactly what the regression coefficient tells us. So this was true across different values of extroversion. We looked first when extroversion was held constant at 20, and then when it was at 21, and it was the same increase associated with satisfaction with social life. Okay, so this is going to be true in any additive main effects model like this. It's going to be true across any possible combination of values of extroversion and number of people talked to. Okay, so the effect of number of people talked to on satisfaction with social life is independent of the level of extroversion. So it doesn't depend, what value extroversion is at. The effect of satisfaction with social life is going to constantly additively increase satisfaction with social life based on number of people talked to. Okay, we could do the same thing while holding number of people talked to constant and varying extroversion. So there's our equation again. Person scoring 20 on extroversion who talked to 5 people. We already did this. They get a satisfaction with social life predicted score of 6.293. Person scoring 21 on extroversion who talked to the same number of people gets a predicted satisfaction with social life score of 6.846. So we take these values, we subtract it based on this 1 unit difference in extroversion, and we get a 0.193 difference. Okay, and predicted satisfaction with social life for a 1 unit increase in extroversion. Again, it matches the coefficient. Okay, I can now look at, say, someone who talked to 6 people, and they scored 20 on extroversion. There's my predicted satisfaction with social life score. What if a person also talked to 6 people, but they had a 21 score on extroversion? Then they would have a predicted satisfaction with social life of 7.085. That difference is 0.193, again, matching the extroversion coefficient. So this is all what we've been learning. It's kind of a recap. This is how we would get actual predicted scores from a regression model, and everything just is additive. Okay. So this was true across the different values a number of people talked to. Increasing extroversion by 1 was always associated with an increase in satisfaction with social life of 0.193. Okay, this is going to be true across any possible combination of values of extroversion number of people talked to. The effect of extroversion is just independent. It just adds up based on extroversion alone. It doesn't matter what our values for the other variables are, like number of people talked to in this example. Okay, so both of those effects for extroversion and number of people talked to are independent of each other. We say they're additive. The effect of one predictor just adds up to change the dependent variable y. Okay, so it adds to the effect of another predictor. Okay, so the predictors don't change each other's effects on the dependent variable. So one variable, for example, does not increase or magnify the other's effects, and one doesn't decrease or attenuate the other's effect either. Okay, so additivity of effects is what we're assuming when we use a main effects model. So note that all predictors, we see all these pluses, they're just all entered and added together separately. Okay, so the predictors are not entered together by multiplication. So no predictor is multiplied by itself in the model, and then no predictor is multiplied by another predictor. Every predictor is just multiplied by its coefficient, really its regression weight, and then that determines how it affects the dependent variable y, or the predicted dependent variable. So when we include an interaction term in a regression model, we throw all that out, and we're no longer assuming just strict additivity. So now the effect of one predictor does depend on the level of another predictor. We could say that the effect of a predictor is not constant across the levels of another predictor. Okay, we could also say that each predictor changes the other predictor's effects on the dependent variable. So all of these are basically just different ways of stating the same thing. Okay, so interactions are entered in regression by multiplying the predictors together. So here's our simplest interaction regression model. Okay, so we have one predictor and then another, and then a coefficient for the interaction term where we multiply them together. Okay, so this is called either the product term. I call it the interaction term a lot, but you'll see it either way. So that means that the effect of x1 on y now depends on the level of x2. So in other words, how satisfied you are with your social life might depend on the number of people talked to, but that effect of number of people talked to on satisfaction with social life now depends on how extroverted someone is. Okay, and then we could say the effect of x2 on y depends on the level of x1. So if I'm interested in predicting satisfaction with social life from extroversion, then my prediction is going to be different based on the number of people someone has talked to. Okay, so maybe if they've talked to a whole lot of people, there's a really strong effect of extroversion on their satisfaction with social life. But on the other hand, maybe if they haven't talked to many people, there's not much of an effect of extroversion on satisfaction with social life. Okay, so the effect of x1 and x2 are not additive. Okay, and we could also say that the effect of x1 and x2 on y are not independent. Okay, so I have a video. Let me pull it up real quick. Let's see. So this is going to illustrate an interaction.
Use the Force. Yes. Now, the stone. Feel it. Use the Force. Yes. Now, the stone. Feel it.
No. We'll never get it out now.
So certain are you? Always with you what cannot be done. Hear you nothing that I say.
Master, moving stones around is one thing. This is totally different.
No, no different. Only different in your mind. You must unlearn what you have learned.
All right, I'll give it a try.
No, try not. Do. Or do not. There is no try.
I can't. It's too big.
Size matters not. Look at me. Judge me by my size, do you? And where you should not. For my ally is the Force. And a powerful ally it is.
All right, that was kind of a long video. Okay, so what does that have to do with interaction? So the effect of size of an object on difficulty of levitation depends on experience. So for those with great experience, like Yoda, size matters not. So size has no effect on difficulty of levitation. The effect of size on difficulty is 0. For those with little experience, like Luke, it's too big. So the effect of size on difficulty is positive. So in other words, bigger objects are more difficult to levitate. Okay, so we could plot this. So say for someone with low experience, maybe this is the relationship between size of the object and then difficulty of levitation. Okay, so strong association between size and difficulty. But then for someone with high experience, like Yoda, the size of the object doesn't have any effect on the difficulty of levitation. So here there's a strong steep slope. Here there's basically no slope, so it doesn't matter. Okay, so the difficulty of levitation is always low, basically. So incidentally, this is also a good example of like a categorical by continuous interaction. So say Yoda and Luke are two different people. This might be, say, like two different experimental conditions. You might have no effect of the variable in one condition, but a strong effect of another. So we'll talk about that next week. Okay, so returning to our extroversion example, let's put an interaction term in the model made by multiplying extroversion number of people talked to together. So this makes sense intuitively. The effect on social satisfaction of increasing numbers of people talked to should be greater for more extroverted people. Okay, it could actually be less for more introverted people. They might, like talking to fewer people. So it may be less for less extroverted people. In general, it should not be constant across the levels of extroversion. So this is the definition of an interaction. It depends on what the level of extroversion is. Okay, so the interaction term added to the model is just the product of extroversion and the number of scores and the number of people talked to scores. Okay, so here are some of our scores. This might look like your spreadsheet, say that you have the data in, or another like data table. Okay, so you have extroversion, number of people talked to, our dependent variable satisfaction with social life. And then to create the interaction term, all we do is actually multiply the values for extroversion, number of people talked to together. Okay, so we could do this in Excel, just type equals the cells for extroversion times the cell for number of people talked to. Okay, and then these are our values right there. So we would do that for each case. Okay, so that's really how simple it is to make an interaction term. So that multiplication sign really just means literally that we just multiply the values of the two variables together. Okay, so here was our main effects only model. So there's our regression equation based on that. And then here is our interaction effects. Okay, so the first thing we should look at with an interaction model is whether the interaction term is significant. Usually if it's not significant, or if it's not even close especially, you probably want to just drop it from the model and just go back with the main effects model. Here it looks like it's highly significant, almost even close to the 0.005 level that some people advocate for. So there does appear to be an interaction. And then here is our regression equation now with different coefficients based on the addition of the interaction term. Okay, so if we calculated scores by varying number of people talked to using this interaction model, so now we're going to just plug different values in and get predicted satisfaction with social life scores, just like we did on the previous slide. So someone scores 20 on extroversion, they talk to 5 people. There's their satisfaction with social life. Now they say someone scored the same on extroversion but talked to one more person. There is their satisfaction with social life score. Okay, if we look at those differences, it's 0.184. So before we got these differences and we could see, oh, those differences are in this regression equation up here, but that's not the case here. So the one additional person talked to is associated with a predicted 0.184 increase in satisfaction with social life, but this doesn't match any coefficient. Okay, So say a person scoring 21 on extroversion, they talk to 5 people. Same score in extroversion, but a person's talked to one more person, so 6 people. There's their predicted score. That difference is 0.197 again. Okay, but it doesn't match any coefficient. Okay, so the predicted effect of increasing number of people talked to by 1 for a person scoring 20 on extroversion was to increase satisfaction with social life by 0.184. For a person scoring 21, so slightly higher on extroversion, that 1 unit increase in satisfaction with social life was associated with a 0.197 increase in satisfaction with social life. Okay, so a slightly stronger effect of number of people talked to for a person scoring higher in extroversion compared to someone scoring lower on extroversion. So the effect of number of people talked to on satisfaction with social life is not constant across our levels of extroversion. It appears that it becomes stronger. That effect of number of people talked to on satisfaction with social life, that slope becomes stronger as people become more extroverted. So extroversion and number of people talked to have a multiplicative rather than additive effect on satisfaction with social life. Okay, so now we did the same thing, but we're going to vary extroversion. So using the same regression equation, a person scoring 20 on extroversion who talked to 5 people, there's their predicted score. And a person scoring 21 on extroversion who also talked to 5 people, there's their predicted score. So that difference is 0.168. Okay, so we could say the 1 additional point of extroversion is associated with a predicted 0.168 increase in satisfaction with social life. Now let's look at this effect of varying extroversion, but now someone talked to 6 people rather than 5 people. Okay, so their predicted score is 7.262. For a person scoring 21 on extroversion who talked to the same number, 6 people, their predicted score is 7.443. Okay, so the 1 additional person talked to is associated with a predicted 0.181 increase in satisfaction with social life. Okay, so again, it doesn't match any coefficient. Okay, so a person talked to 5 people, and we increased their extroversion score by 1. That led to an increase in satisfaction with social life of 0.168. Here, for someone who talked to more people, the increasing extroversion by 1 had a stronger effect on satisfaction with social life. Okay, so the effect of extroversion on satisfaction with social life is not constant across levels of number of people talked to. Therefore, they have a multiplicative effect. Okay, so with the interaction, the effect of number of people talked to on satisfaction with social life varies depending on the level of extroversion. Okay, so here we're thinking about, this is how we normally think of, say, correlations. What's the effect of one variable on the other? Okay, or like a one predictor regression. Now that effect or that relationship or that slope for number of people talked to on satisfaction with social life, it varies depending on how extroverted people are. Okay, we could also state it in the opposite way. So now we're interested in the effect of extroversion on satisfaction with social life. So, are extroverts just happier or less happy, less happier than introverts with their satisfaction with social life? But that effect or that slope varies depending on the level of number of people talked to. Okay, so significant interaction can always be interpreted in either of 2 ways. So this is just like when we interpreted simple effects in ANOVA. We could do simple effects of each variable, of one variable within each level of the other, or we could do it vice versa. Okay, so we interpret the coefficients in the model in much the same way we do in a quadratic model. So the highest order term, the interaction effect, is unconditional. Then lower order terms, so the separate effects of the predictors, those are conditional. And then, of course, the intercept is always going to be conditional. Okay, so here is our regression model again. Okay, so there are coefficients B0 through B3. So B3 is unconditional because the interaction is of order 2, okay, the highest order in the model. And then B2 is conditional because there's a higher order term involving number of people talked to in the model, namely the product term or interaction term. B1 is conditional because there's a higher order term involving extroversion in the model. And then B0 is conditional because there are predictors in the model. And so it's just the intercept. Okay, so the easiest way to interpret the coefficients is to rearrange the equation to focus on the predicted effect of one predictor on the dependent variable at different values of the other predictor. So that's what we're going to do now. So I say this easiest with, some caution. Maybe this doesn't appear easy, but hopefully you can kind of go over this, enough to where it does become easy to understand what interactions are. Okay, so focusing on the predicted effect of extroversion on satisfaction with social life. Okay, so if we rearrange this, okay, we could rearrange this equation basically by factoring out extroversion from this part right here. Okay, so we haven't done anything with this left side, but now we've factored out extroversion over here to where it's 0.103 plus 0.0103 times number of people talked to times extroversion. Okay, so now we've rearranged this equation. It's the same equation. We've just done a little math. So when we rearrange it like this, we can consider the part not multiplied by extroversion. So this part over here, we can consider that the intercept. Okay, and then we can consider the part multiplied by extroversion, the slope. So this is like how we normally interpret just one predictor regression equations. We're interested in the effect of extroversion on satisfaction with social life, but we have to take into account number of people talked to because that interacts with extroversion. Okay, so now since we have this part multiplied by extroversion, we can treat this part of the equation as the slope. Okay, so the slope is not constant, but see, it depends on number of people talked to. Okay, so this slope predicting satisfaction with social life from extroversion will depend on how many people someone has talked to. Okay, so the intercept also depends on number of people talked to. So you can see that in the intercept as well. So we can substitute in values of number of people talked to see what the regression equation would be. So say number of people talked to equals 3. So this is like the pandemic version, I guess, where you talk to very few people. So what's the regression of satisfaction with social life on extroversion? Well, I could just plug in 3 to this rearranged regression equation, and it'll reduce to this right here. Okay, so now I have a nice simple regression equation, and I could plot this using plot this simple slope as well. Okay, so that's kind of what we'll do later. Say we have someone who talked to 8 people, so kind of a moderate number of people talked to. Okay, what's the regression of satisfaction with social life on extroversion? I plug in 8 for number of people talked to, and I get this. Okay, so we can see already this slope for extroversion predicting satisfaction with social life from extroversion. The slope went up based on number of people talked to. Okay, so in other words, if I've talked to more people, there's a stronger effect of extroversion on my satisfaction with social life. What happens if I talk to 11 people? Okay, I plug in 11 to this rearranged regression equation, and now I get a slope of 0.246. Okay, so as you talk to more people, there appears to be a stronger effect of extroversion on satisfaction with social life. So there's our 3 simple regression equations. So these look like one predictor regression equations, but each only applies for a particular value of number of people talked to. So because they only apply at a particular level of another predictor, they're simple regression equations, and then their slopes are simple slopes. Okay, so I can see that the simple slope increases for predicting satisfaction with social life from extroversion as I talk to more people. Okay, so these are like simple effects in ANOVA, or simple slopes, just like we did in a quadratic model. Okay, so I could take those simple regression equations and I could plot them. So there's our plot for number of people talked to equals 3. There's our plot for number of people talked to equals 8. And then there's our plot for number of people talked to equals 11. Okay, so as we talk to fewer people, the effect of extroversion tends to become smaller. But then as we talk to more people, the effect of extroversion becomes larger. Okay, so we could kind of state this contextually. The more people a person talks to, the stronger the association between extroversion and satisfaction with social life. Okay, so high extroverts have greater satisfaction with social life when they can talk to a bunch of people. Okay, say we have those simple regressions. Okay, so I could rearrange it like that way. So looking at the simple regressions allows us to interpret B1. So B1 is for extroversion right here. So B1 is the slope of the simple regression of satisfaction with social life when the other variable, number of people talked to, equals 0. Okay, so a number of people talked to equals 0. I can plug 0 into the rearranged regression model right there. Okay, and so I get 0.103, and so that's my coefficient for B1. So in a quadratic model, B1 tells the slope when the same predictor is 0. Here in a model with an interaction term, it tells the slope when the other predictor is equal to 0. So that can sound kind of counterintuitive, but it's important to keep thinking about that until you really understand what it's saying. Okay, so we could go back and reorganize or rearrange the regression equation in the opposite way to focus on the predicted effect of number of people talked to on satisfaction with social life. Okay, so right now we treated kind of extroversion as the proximal predictor of what we're interested in looking in, and then number of people talked to was just a contextual predictor. Here we're going to flip it, so we're going to treat number of people talked to as a proximal predictor and extroversion as the contextual predictor. Okay, so there is our rearranged regression equation. So here is our original equation. So basically what we did first, so we had extroversion over here, number of people talked to over here. So again, we just factored out number of people talked to. Okay, so this becomes our intercept, and then this becomes our slope. Okay, and then extroversion is, again, since it's the contextual predictor, it's now in each one of those. Okay, so say extroversion equals 20, so kind of a low value. Recall that our scale was from 0 to 100. So this would be, say, someone that's more introverted than extroversion. What is our regression of satisfaction with social life on number of people talked to? I plug 20 in there, and then I get this simple regression equation. Okay, just with number of people talked to. Say extroversion equals 50, so someone's kind of right in between being fully extroverted and fully introverted. Okay, now the simple slope is 0.574. Okay, so note that that's much larger than the slope for someone low in extroversion. Now someone's really high in extroversion. What's the effect of satisfaction with social life on number of people talked to? Plug in 80. Okay, and I get this simple regression equation. Okay, so to plot those, there's a pretty shallow, probably maybe even non-significant if I looked at this simple regression. Okay, so for extroversion equals 20, really not much of an effect of number of people talked to on satisfaction with social life. Okay, so in other words, introverts, it maybe doesn't matter how many people they talk to. Okay. Someone who's kind of right in the middle, so they score a 50 on extroversion, they have a stronger effect of number of people talked to. And then someone who's really extroverted, they have an even stronger effect of number of people talked to on satisfaction with social life. Okay, so this actually, serendipitously works out that this is a pretty interesting example, given our current state of society. So, introverts are right here. Doesn't matter that they don't talk to many people. Their satisfaction with social life is about the same. Whereas maybe someone's really extroverted, they're not talking to as many people, and so maybe their satisfaction with social life is much more strongly affected than someone who's very introverted. Okay, so we could say the more extroverted a person is, the stronger the association between number of people talked to and satisfaction with social life. Okay, so looking at these simple regressions allows us to interpret B2. Okay, so number of people talked to here. B2 is the slope of the simple regression of satisfaction on social life when the other variable, extroversion, equals 0. Okay, so when I plug in 0 for extroversion like I did right here, okay, I get this value, and that coefficient is equal to B2, just number of people talked to. So again, this is very important. When you have an interaction term, these lower order coefficients do not mean the same thing as they would if they were just in a multiple regression model or in a single predictor model. Here they just tell us the relationship between one predictor, number of people talked to, when the other predictor equals 0, basically. Okay, so they're only telling us about one specific case when the other predictor is equal to 0. Okay, so like B1, B2 is a simple slope in a simple regression. Okay, so in a quadratic model, there's only one simple slope. In an interaction model, there are going to be two. Okay, so the rearranged regression equations also clarify the interpretation of B3. So that's our interaction term. Okay, so right there. So B3 is the change in the association between number of people talked to and satisfaction with social life for a 1 unit increase in extroversion. Okay, so note that it's the association, meaning kind of, you can think of it as the correlation, okay, or the one predictor regression. Okay, so B3 is a change in the association between number of people and satisfaction with social life for a 1 unit increase in extroversion. Okay. We could also say that B3 is the change in the association between extroversion and satisfaction with social life for a 1 unit increase in number of people talked to. Okay, so these are really saying the same thing, just in different ways. Basically, if we're focusing on number of people talked to up here and its association with satisfaction with social life, or extroversion down here and its association with satisfaction with social life. Okay, how does that relationship change depending on a 1 unit increase in the other variable in each case? So the size of this B3 interaction term coefficient is typically difficult to interpret. Even the sign of B3 can be kind of tricky, and really it isn't good to kind of use any heuristic. So if the sign of B3 matches the signs of B1 and B2, then the variable's combined effect is more in absolute value than the sum of their separate effects. So it's a synergistic interaction. So that's what this current example is. Okay, so everything was positive in this current example. So as we increase one variable, the relationship between the other variable and the dependent variable becomes stronger or more positive. Okay, if the sign of B3 is opposite the signs of B1 and B2, then the variable's combined effect is less in absolute value than the sum of their separate effects. Okay, in other words, it kind of attenuates the effect. Okay, so note that the signs of B1 and B2 can change when we center. But just like in a quadratic model, rather than interpret B3 directly, what we do is we find the simple slopes at particular points on the regression surface and then interpret them. So we're going to do the same thing, probably not in this lecture, but in the next one. We're going to do the same thing we did with quadratic models, where we pick, say, the mean and plus or minus 1 standard deviation, and then we center one variable based on those values and keep the other variable mean centered. So we'll talk about that in the next lecture. Okay, at least interpreting the intercept is a piece of cake, so like that piece of cake right there. Okay, so just like in any other multiple regression model, B0 is the predicted value of the dependent variable when all predictors are equal to 0. So for a person scoring 0 on extroversion, meaning they're the highest they could be in introversion, and talking with 0 people, the predicted satisfaction and social life score is 4.098. Okay, so maybe that's of interest, maybe it's not. Okay, if either predictor equals 0, then the interaction is also going to equal 0, because we're going to be multiplying by a 0 here. So there's our simple interaction regression equation again. So B0 is a predicted value of y when x1 and x2 equals 0. B1 is the predicted change in y for a 1 unit change in x1 when the other predictor x2 equals 0. So it's a simple slope when x2 equals 0. B2 is a predicted change in y for a 1 unit change in x2 when x1 equals 0. Okay. And then B3 is the change in the predicted change in y for a 1 unit change in x1 for a 1 unit change in x2. Okay. So maybe if we state that in a little bit, breaking it down a little bit more. So the predicted change in y for a 1 unit change in x1. So this is basically what is the correlation or the relationship between y and x1. Okay, for a 1 unit change in x2. So how much does that relationship change? Okay, so we could also say B3 is the change in predicted change in y for a 1 unit change in x2 for a 1 unit change in x1. So the predicted change in y for a 1 unit change in x2. So this is just like if we're interested in the relationship between x2 and y, how does that change for a 1 unit change in x1? Okay, so that relationship will change depending on what x1 is. Okay, so here's our rearranged regression equation again. Okay, so I moved b2 x2 over here, then moved b1 over here, and then factored out x1. Okay, so b1 plus b3 times x2 is a simple slope for predicting y from predictor 1. When x2 equals 0, the simple slope is b1. Okay, so b3 tells how much the simple slope changes for a 1 unit change in x2. Okay, so if x2 equals 0, the simple slope is just b1. If x2 equals 1, the simple slope is b1 plus b3. If x2 equals 2, the simple slope is b1 plus 2 times b3. So implicitly up here is 1 times b3, but we don't need to write the 1 times there. Okay, and then up here is 0 times b3, but that just becomes 0, so we don't need to write it there. Okay, so going down, if x2 equals 3, the simple slope equals b1 plus 3 times b3. Okay, so I multiply this value for the interaction term by the value of the other predictor, and that determines how the simple slope changes. So B3 can be positive or negative, so increasing predictor 2 can make the simple slope more positive or negative. So if B3 was negative in this case, we would be adding a negative number, or basically subtracting from B1 and making that simple slope smaller as the other variable x2 increases. Okay, so rearranging again, okay, but in the opposite way. So b2 plus b3 times x1 is a simple slope for predicting y from x2. Okay, so when x1 equals 0, the simple slope is b2. b3 tells how much the simple slope changes for a 1 unit increase in x1. Okay, so if x1 equals 0, simple slope equals b2. Okay, because we're adding plus 0 times b3 implicitly here. Okay, if x1 equals 1, the simple slope equals b2 plus 1 times b3. If x equals 2, the simple slope equals b2 plus 2 times b3. Okay, and if x equals 3, the simple slope equals b2 plus 3 times b3. Okay, so b3 can be positive or negative. So again, increasing x1 can make the simple slope more positive or more negative. Okay, so both interpretations of b3 are equally valid. We only need to report, discuss, or plot one of them. Okay, it might be confusing to a reader to report both. So this reader is going to be like, oh, you interpreted things both ways. I don't know what you're doing here. Okay, so how do we choose which one? We can follow convention when possible. So, it might be that you're kind of really interested in one variable, and then this other variable is something that you think you need a control for, or it interacts with that variable. So you can focus on the variable that you're more interested in. Okay, so very often one predictor is treated as a proximal cause, and then the other is treated as a contextual cause. Okay, so the proximal cause is like what we would typically be interested in. So how interested are we in the effect of extroversion on satisfaction with social life? Or, maybe given that people will tend to talk to fewer people now, given our current circumstances, maybe number of people talked to is the proximal variable, because that's what is drastically being reduced. And then extroversion is our contextual predictor, because it's something that's more long-term, a stable or semi-stable personality trait. Okay, so it's not something that's going to change based on this pandemic, but number of people talked to will. So we might want to treat that as the proximal cause. Okay, so you can pick the predictors that match these roles the best. So this is something that involves subjectivity. There's not like a clear answer, basically. Okay, and we can always look at it both ways and report the one that is the clearest. Okay, so report simple slopes for predicting the dependent variable from the proximal predictor, and B3 is the change in those simple slopes at different levels of the context predictor. Okay, so which one should you have? Well, you can determine the proximal and contextual variables by convention or theory when available. So if number of people talked to is more proximal or kind of more the thing you're really interested in, and extroversion is more contextual, report B3 is how the simple slope for predicting satisfaction of social life changes from number of people changes as extroversion changes. Okay, alternatively, if extroversion is more proximal, number of people talked to is more contextual, then report B3 is how the simple slope for predicting satisfaction with social life from extroversion as number of people talked to changes. Okay, so we'll go ahead and stop there for today, and then in the next lecture we'll pick this back up, and then I believe we have some examples in JASP and R, and so we'll do those in the next lecture. All right, thanks for listening and bearing with me in this alternate presentation format. That's all for today.